with the, we're using an Intel NUC, the one that used to be on Killer Crawler. I believe it's an i5 processor, and it could do the image acquisition and all the processing and the rotation correction in about 0.2 seconds using Python and PyOpenCV. So it could be potentially sped up. And particularly, you know, done on an FPGA or something specific and then done extremely fast and extremely small.
And I'll pick up with that extremely fast, extremely small.
Sure.
Your opening and your title represented continuously as a distinction. What do you mean by continuously?
So the continuous was relative to the speed of the rover and the prior literature of longer distances between sun, measuring sun on the order of 20 to 30 seconds or longer. And so we were running, every second we were recording, and so our maximum turn rate, I believe we're only able to, I forget the exact number, but it's kind of really relative to the max turn rate of the rover throughout the field test. I guess they didn't define a hard definition of what continuous meant. I kind of implied it more as a fraction of the turn rate of the rover. So if it would be above a certain fraction, then essentially you're continuously measuring the change in heading versus measuring it before the turn and measuring it after the turn.
And do you believe that you can parameterize or even non-dimensionalize that idea relative to those kinds of parameters?
Yeah, I believe you could do that fairly straightforwardly.
Well, are you going to?
Sure.
Okay. The Heather's question is really enchanting. At what frequency might this kind of a sensor determine bearing? I'll really throw it out there. I mean, could this ever approximate an accelerometer?
Well, our results, if you look at the fine scale, which I don't have it immediately visible, but the IMU and the solar compass, the data looks almost identical except for the drift. So even the very small movements at the rover.
Could you put what used to be 28 up there while you chat about this?
Sure.
Yeah.
Yeah, so even on a finer scale, here we go. Yeah, even on a very fine scale, I might actually have.
This is
Well,
fine.
is it
28
okay?
is fine. Time, we're running short on time.
Oh, okay, sure.
The-
So yeah, that was one of the points, is you might be able to replace a heading gyro with the sun compass. And one of the questions was, how good of an accelerometer do you need to be able to pull that off?
Well, about the how good, something that's missing for me on this one is the ground truth. So ground truth is incorporated in many cases as a comparison. And here we don't get it.
I did compare it, but it's very messy because of the noise in the ground truth.
Well,
And
that comes.
I can.
That comes
I can
back to
include
the
that.
filtering ideas, and which are subtle, because to really get a grip on this, you have absolute and maybe very accurate absolute, just not instantaneously and perhaps not currently filtered over an appropriate band of the data.
Sure, and I regret not putting that in here. That didn't make the cut, was the ground truth on this. It was good for sections of, they were very good about sections about this wide, and then it went crazy, even though I was filtering the ground truth position data to smooth it out, and then numerically taking the derivative of it. I wasn't able to get a very good noise-free comparison, but the ground truth it laid almost more or less exactly over the absolute heading. So the ground truth would go up and down at a high frequency, because the mast swang so much.
Mhm.
Even if it was filtered, it was still picking up the side-to-side movement with the heavy filtering. But yeah, it was essentially, it was almost perfect. I really should have put that picture in here, because,
But yes.
Did you look at all at putting a magnetic compass on the robot to have an actual heading reading? Because your ground truth right now is just a position ground truth, and then you're having to differentiate to get your,
right, yeah, so we didn't, there was
Sure.
no, yeah, it was doing a
Difference in
point-to-point
position.
difference to find the ground truth. And like I said, the noise was heavily amplified because of the swaying of the mast. But no, that would have been a great thing to have. Also probably a GPS compass or something that could, maybe a differential GPS would have been great. To get that information. Although it still might have had problems if it was at the top of that mast, swinging back and forth. But no, that's a very good point.
Anything else from committee?
I think I can let it go to the floor for my part.
Kurt, can you go to the thank you slide? Actually?
Sure.
Or the comments or whatever it said, the one with the pictures. Yeah.
Yeah.
So I'm wondering just what you think, I'm not sure if you did any great analysis on this, but what you think are the contributions of error to this method? Because you can see here that this is, it's hard to tell, but I'm assuming that these are near the edge of, all these measurements are near the edge of where the.
Yeah, they do fall right on the horizon, and when you go down a hill just a little bit, what actually saved us was the glare on the lens.
Okay.
So even when we were beyond the horizon, there was enough glare and reflection centered where the sun, excuse me, was out of, like there was enough instant light coming in, and you can see that right along here, because you can actually see it was actually a four lamp light, and that's why you see these little pairs.
So my question is,
They drop off here, but we still got all of these measurements with just these small little bands that are sticking up here.
yeah, my question is, there's a lot of possible sources of error, like finding the centroid of this thing.
Mhm. And that
doing
does vary on here.
Getting the gravity vector.
Yeah.
And even when you're looking at this fisheye calibration, the fisheye calibration is generally least accurate in the area of the image that you're
Right.
considering here. So do you have any?
Well, the nice thing is it's not,
Do you have any
it's not
idea of what
affected,
the,
sorry, go
what
ahead.
the general contour, what is the major error? How well do these?
Right, and that we didn't quantify really. We did more of the experimental, but that would be interesting to look at the contributions of the different error sources. One of the, that would be a good thing to look at.
Others? Going once? Going twice?
I got one. So looking at the same image, all of these, some positions are low on the horizon. How do you think it would affect performance if they were very low?
Same images, please.
Sure. Sorry.
How do you think the performance would be affected if the sun was straight overhead?
Right, so if you were at the equator and it were noon, you would get towards the singularity where you will use the arctangent of displacement, from the centroid, from the center here. And yeah, when the sun, as the closer the sun gets here, the uncertainty is just gonna grow hyperbolically, but with the tangent. So there would be probably a certain latitude that once you cross that, then and a certain time that it would become unusable, or you'd have to go with a different method to maintain enough precision in your route reconstruction. So that is a good point, because essentially the closer the sun gets to dead overhead, the less pixels you have in X and Y to find it. So the ratio of the number of pixels from center to centroid in each direction just keeps shrinking and shrinking. So you'd end up with really strong aliasing once you got towards the center, where just being a few pixels off could be 40 degrees or, in an extreme case.
So there's certain times, combinations of times or latitudes where it just wouldn't work very well.
Yeah, I think that would definitely be the case. I think on the moon, it may be, well, I know Apollo, they couldn't drive during the midday because of lack of shadows. That may not be an issue for rovers, but yeah, that's definitely a good point, that certain latitudes and times would have a hard time with the solar compass.
It might be useful to figure out, not necessarily a solution, but at least characterize when those.
Right,
latitudes are.
right, yeah, yeah.
Kurt, do you think that this might be better than you are attributing or claiming based on the very small rover that has a substantial rocking, rolling, climbing, pitching by encountering terrain, as opposed to priors, which had larger rovers that, or larger wheels that weren't inducing that much.
Was the question is this, am I interpreting this as?
Right now,
performing-
everybody in the
Yeah.
world talks about the quality of localization or path registration as a percentage of distance traveled.
Right. They don't qualify.
I get that it's distance traveled, but distance traveled by a giant truck with a 10-foot wheel isn't the same as distance traveled by a toy with a 4-inch wheel. In terms of how much local pitching, kicking, rocking, and the like. And so, do you imagine there is any difference, in any different metric of merit that is other than percentage of distance traveled?
Yes, I would say it's heavily tied to the relative rover wheelbase and wheel diameter compared to the distribution or the likelihood of the height of obstacles that were driven over throughout the course. I think that would have a big effect.
All right. With that, thank you very much. Thanks everyone for being here.